Let's talk about the kidney today. Quick reminder on the dog. We had our bean-shaped kidney like so. Ureter entered the kidney and expanded into a renal pelvis. And we had our cortex out here, medulla to the inside, and then the renal crest is dipping into our renal pelvis at that point, and that's where urine was dumped into the collecting system. Now in the equine, the kidneys are not shaped like this. They will have their poles bent around the corner of the ureter on each side. On the right side of the horse, in the shape of a heart. On the left side, it's kind of bent off, elongated into a bean shape. And so these poles get pulled farther away from that renal pelvis than they were in the dog.
So here's our picture of the horse that I drew half off camera. So I'm inserting it here like this, complete. You can see our ureter coming into the kidney, the renal pelvis, the expanded proximal end of it here. But because the horse kidney is wrapped, the poles are so far away from the ureter, unlike the dog kidney up here, we have a lot of medulla over here away from this relatively smaller renal pelvis here. And so what you will find is a cavitation through the medulla that lines up with the renal pelvis. And so all the collecting tubules that are dumping into our renal crest here will dump the urine right into the renal pelvis. The collecting tubules over here will dump the urine into this, what we call a terminal recess. And the urine will trickle through there and then on over here into our renal pelvis and on out the ureter. So this gap within the medulla almost looks like a fracture line, and you've got to cut it just right to find this. It'll be hard to see in most of these kidneys, but if we get a good one, I'll show you in lab. So terminal recess, out into the poles of the kidney of the horse. The dog did not have that, didn't need that. And the one thing you don't want to confuse those with will be branches of your renal artery or vein, but those will have a shiny interior where your endothelium is covering and lining those vessels, whereas this will just be kind of a matte, flat-looking surface in the horse kidney. So terminal recess, a new structure in the horse.
Renal pelvis is sitting here. Terminal recess is coming off each side down there. They won't be that pretty and shaded in when you see them in the gross lab, but we will see one in there. Okay, so this was our dog. This is the horse. The bovine. I'll just put cow. It's the female, but it's bovine. That kidney is going to look like a cluster of grapes. The reason being is in renal development, kidneys will start out like this and they will fuse together. So if I take one of these little lobules right here and cut it on cross section, what you actually have is a little cortex. You have a medulla, and this piece down there is the papilla. Every one of these has this structure. Now what happened in the dog and the horse, you had one here, and you had one here, and you had one here, and all the cortices fused together into one structure. All the medullas, all the medullas of these fused into one structure. And then all the papilla, these fused into the renal crest. And so in your dog book, it mentioned the renal pyramids. And I told you the only way that you would be able to see those is if you saw the branching of the renal artery coming up between those things and delineating them. And that's just a lucky cut to see that. So in the cow, these things just didn't fuse together. They stayed separate. They'll be stuck tightly side to side, but they will not be fused in one structure. So this is what the bovine kidney looks like right here. So how are we going to collect this urine from a structure that looks like this that has several of these in it? Well, here's what the cow is going to do. When that ureter enters the kidney, this is ureter. It enters the kidney and it has a cranial and a caudal branch. So cranial branch of ureter. The other one's a caudal branch. And off of that, we have all these little cups, like so. Each one of those is called a calyx. Calyces is plural. So each of those little cups, that's the calyx, it's sitting there with that papilla in it, like so, collecting that urine. The next one over here is sitting like that. So the cow will have a cranial branch of the ureter and a caudal branch of the ureter, and all these little calyces coming off of it. So if I look down in here, the ureter is cut there, and you can see a cranial branch here, a caudal branch here, and you can see all these little stems here where all the different calyces are coming off, and you can see the little pit right there in the white where a little renal papilla sat down in there. So cranial and caudal branch of the ureter. If I tag this on a test, I will not ask you cranial or caudal branch, which is which. Cranial tends to go to the smaller end of the kidney, and the other giveaway, if you've got more ureter, is the ureter will come out and bend caudally. I just want you to know that those are branches of the ureters. So this is what it looks like when you get into the inside of the kidney of the bovine. I didn't draw that right, I just kind of squiggled it in there. The pig kidney. The pig kidney is trying to, I guess, dip a little bit into both worlds. When you look at the pig kidney, it looks like the kidney of the dog pretty much. It's one solid piece. It tends to be longer, and that's one of the dead giveaways of the pig kidney. It's a little bit longer than it would be with this width in a dog, and they tend to be flattened dorsoventrally. Now the kidneys in these animals, if you recall the dog kidney, it's the right one sat farther cranial than the left. That will be the same in the equine and the ruminants, but in the pig, these kidneys almost sit side by side. They're almost symmetrically placed in a cranial caudal direction inside that body cavity. So that's another thing they've got different. Now, if you took a look at the inside of this pig kidney, you would see a cortex like this, and you would see all these little separate medullary pyramids coming off the inside. So the cortex fuses into one structure like we had in the dog, but the pyramids and the little papilla at the end are separate like we saw in the cow. And that's not all he's going to do. When the pig's ureter comes in, it comes in and it's got a pelvis. So we're just off in one pole over here. He's got a pelvis, but then there is a big expansion coming off that pelvis running over here, and there's a big expansion running over here. And off of that expansion, we get the little cups. Like this. So the terms we will use here is we've got the ureter, we've got the renal pelvis, ureter, renal pelvis. This is a major calyx, and this guy right there is a minor calyx. So instead of having a branch of the ureter, it's more dilated than that branch is in that bovine kidney. So they're calling this a calyx, a big collecting vat, and then we have these minor calyces coming off of them. So the bovine has the analogous structure when compared to the pig, just this minor calyx, but since the bovine does not have major and minor calyces, we just call this a calyx and leave it at that. But it's analogous to the minor calyx of the pig. So pig from minor calyx to a major calyx to the renal pelvis to the ureter. There's another major calyx over here at the other end of this kidney that didn't draw, and the rest of the kidney would be over here like so. So that is what you need to know about the kidneys of these large animals. I did not mention the goat or the sheep, so I'll do it now. The goat kidney and the sheep kidney look like one another, and they look just like what we saw in the dog. And if you took a kidney out of a goat or a sheep and laid it on a table, I would not be able to tell the difference between it and a dog. On the inside, looks just like a dog as well. So nothing new about the goat kidneys, and that's what we will see when we dissect these animals at the end of the semester.